I'm Stephen Foskett, the organizer of Tech Field Day, and we're here in Austin, Texas with StorMagic. Around the table are a group of invited writers and speakers from around the world to ask questions and learn about the products. If you'd like to learn more about our event, just go to techfieldday.com, and you can find many more videos like this at youtube.com/techfieldday.
Everybody, my name is Jason Shaw. I'm a technical marketing engineer at Cisco, and I focus on UCS software, specifically the systems management products. I've been working with the UCS B-Series platform that was mentioned for many years. I started with Nuova Systems, the acquisition that Cisco made back in 2009. And I've had the good fortune of working with most of the UCS products along the way. So I've got a set of slides, and I've got a short demo video towards the end that we'll run through. But from a kind of an agenda standpoint, I want to cover why Cisco servers for StorMagic. We'll talk a little bit about the Cisco validated designs and deployment guides that we have available for the solutions. I'll talk about the Cisco IMC, that's our BMC or our out-of-band management controller for our rack mount servers. A little bit about automation, what capabilities we have for programming against that BMC, which I think is very relevant when you've got lots of servers and remote offices. You want to have very, very granular control of the configuration. And then how do we do that at scale? We'll talk about Cisco IMC Supervisor, our product for managing remote servers at scale. Great, so why Cisco servers for StorMagic? And I think this is a quote that you'll see certainly out on the StorMagic website. But basically Cisco has identified StorMagic as best of breed for those remote office, branch office scenarios. Using our Cisco UCS Unified API, we're able to provide, a broad set of server models to address all the different use cases: heavy compute, light compute, heavy storage, light storage. So we've got a broad range in our portfolio to cover all the different use cases. And that last bullet there, we can provide a similar user experience regardless of which server models you might be using out in those remote locations. I'm going to hit kind of the portfolio at a high level. So on the low end, and this might have been mentioned earlier, the E-Series servers. These are server modules that go inside of those ISR routers. Quite a wide range of compute and storage offerings in a very small form factor. They have half-width modules, full-width modules, and hitting some various use cases for memory size, core count, number, and size of storage within those modules. And certainly for hitting those, low-cost price points, it's a fantastic product. And what's interesting, I think, about the E-Series, the C-Series, the S-Series that you've heard about is they use common software. That BMC has common BIOS code, common IMC software code. So when we write automation tools and plugins, they tend to work across all of the different product lines. Over to the C-Series rack servers. Again, I think we had a quick high-level slide earlier on this, but these are our probably run rate rack mount servers, the C220 M4, the C240 M4. The difference being primarily the amount of PCI cards, hard drives that you can fit inside them. And if for 4-socket, for very CPU-intensive workloads, we have a 4-socket server that you can find out there. We mentioned the S-Series server, a fairly new product to the portfolio, massive amount of storage. It's a modular design, so you actually have the ability to install multiple server nodes inside of this 4U box. 600 terabytes of storage. There's up to 60 3.5-inch drives that can go inside of this. Very configurable. The drives can map to one or the other or to both servers, depending on your application needs. Again, lots of configuration options there. Different size drives, different size server nodes from a CPU and memory perspective. A very interesting and relatively new product to our portfolio. And UCS Mini, which was mentioned. So for those branch office environments that need a lot of CPU power, this is a very interesting product. Again, it may be overkill for some applications, but certainly you can fit a large number of servers in that remote office, branch office, and have the benefits of UCS Manager controlling that configuration, policies, and profiles associated with that infrastructure. A data center in a box, if you will. And we'll talk about some of the Cisco validated designs and that are available, deployment guides that certainly apply to a mix of these products in the portfolio. So the second, in fact, we're leading right up to that, Cisco validated design and deployment guides that we have available. So certainly if you go out and hit your favorite search engine for Cisco validated designs, you'll find a main page, covering a lot of the Cisco portfolio, all of the Cisco validated designs and deployment guides that have been written. So we work closely, certainly with StorMagic in this case, and put together the best practices, needed to deploy this product properly on some of the different products that we have on our portfolio. So the three that we're identifying here, StorMagic vSAN on our UCS C240 M4. We've got StorMagic on UCS Mini, and then using the C240 as a storage node, presenting storage to UCS Mini in this case. So these are out there, and again, provide relatively written not too long ago, but covering some of the later versions of vSphere, and most importantly, have all literally the cookbooks for installing the product and according to best practices. Great, so a little bit about our Cisco IMC integrated management controller. So as mentioned before, every server has an out-of-band management controller, a BMC, if you will, a base management controller. We call ours the Cisco IMC, or the Cisco Integrated Management Controller. We've just recently launched a new version of our software, the 3.0 release. Lots of new features, a few that I'm going to highlight. Most importantly, we've been able to move our management interface and our KVM to HTML5. So I think a big accomplishment there, and something that a lot of our customers really wanted to see us move to. But there's certainly a lot of great features in here. XML API transactional support. I don't have a demo of that, but ultimately, for anyone that might be familiar with the UCS Manager product, we've had a very robust XML API since we launched the product, with the ability to basically send, let's say, a complex set of XML for configuring the product that may have multiple tasks inside of it. We've actually extended that capability here, even with a standalone C-Series. With and those out-of-band management controllers on the rack mount servers, there's not a lot of horsepower, generally on those. So I think we've been able to build a lot of capabilities in that small, engine that runs on the motherboard, if you will. So certainly the HTML5, Web UI, and KVM, very important features for us. Something I'll be talking about in a little bit is NISCU. So that SCU refers to our server configuration utility. Think of that as the CD that you would get with the server to do that initial installation of an operating system. SCU, in our case, is something you download from our website, and it lets you, deploy basically any supported operating system, with ease. NISCU, as we'll talk about in a little bit, is a way of using that CD in an automated fashion, non-interactively. So I don't have a demo of that, but I do have, this is actually something that just recently launched. I've run through it, and we'll talk about that in a little bit. So that HTML5 Web UI, certainly a great new feature of the product. I'm going to show you a demo of our integrated management controller. Some of the features there, but ultimately it's one-stop shopping for configuring the hardware, configuring things like BIOS settings, your RAID controller, getting access to power controls, launching the KVM. Anything you need to do out of band, maybe pre-OS, or even after your OS is up and running. Looking at sensor data, understanding health, all those things can be gotten from our Web UI, from remotely. And again, that covers all of our supported platforms. Generally, the M3 and the M4 servers can benefit from that 3.0 release. Actually, the M4 servers, as listed here, supported platforms. C240 M4, C220 M4, the C460 M4 that we talked about, and the two flavors of that S-Series product that we mentioned earlier. Now, StorMagic on Cisco UCS, the next area here, we'll talk a little bit about our API and what tools we have available for getting information from an IMC, programming the IMC remotely. I think one of the investments that Cisco has made in general across all of the server portfolio is in APIs. For the UCS B-Series product, we've always had a very comprehensive XML API, and all of the management tools that we've written are really just clients against that API. Similar concept here. We've written a PowerShell library that's able to talk to basically all of our products, most importantly in this case, the Cisco IMC. In fact, in the current releases of our PowerShell library, you go to cisco.com, you download basically a single MSI that installs a suite of PowerShell clients. PowerTool is the marketing name that we have for basically our PowerShell library. So the suite that you'll download will support automating against UCS Manager, Cisco IMC, or another higher level management product referred to as Central. But again, one install gets you all of the products. It's very interesting, I think, to me, when you look at how we build these products. We take the, if you will, the XML schema files that define what can be read and written into our XML model. We feed that into an engine that produces the code needed to build the library. And the value there is, as we come out with new capabilities, there's not a lot of handwritten code that needs to happen. A lot of the code is actually automatically generated using automation that our engineering teams have built. And the other important piece there is these libraries can automate anything that is automatable, in the IMC. So they're very comprehensive. The common use case is certainly initial server configuration. Setting up your BIOS tokens, your storage controller, your boot order, firmware updates. I think any sort of ongoing, any sort of day zero provisioning, day one configuration, day two configuration of a server can be automated using UCS PowerTool in this case, or our PowerShell library. So for folks that might not want to do their automation from a Microsoft or a Windows focused environment, we also have a Python SDK. Recently rewritten in the last 1 to 2 years, very Pythonic. This is actually hosted up in GitHub. So certainly we want to have it in the places where that community is looking for such an SDK. So again, a full set of Python modules to automate our C-Series and our E-Series servers. Again, they're automating against the UCS Unified API. They're PIP compliant, they're Pythonic, and again, hosted up on GitHub. We're spending a lot of time in this area. We're looking at a lot of ways of automating the full stack. So I think you'll find a very comprehensive SDK that will appeal to folks that are into automation, the DevOps world, the scripters. I think we've got what they need to have full control over the hardware. This is another tool that's actually built into the Cisco IMC. You can point your browser to the IP address of your out-of-band management controller and walk through the UI and configure the hardware. But for folks that want to dig under the covers and actually understand what is in this, the XML model that's represented inside of our IMC, ultimately there are sets of classes, basically XML objects, classes, with properties, and by using Visore, this API browser, I can quickly go through the system, browse everything that's available, and discover the types of things I might want to automate against, or maybe collect using automation tools. So kind of an interesting tool that's built in to let you discover XML, for querying a certain set of information, or what's available in that model. And this is, I think this class I have in the screenshot here is literally just representing the top level information about the hardware, the amount of memory, the number of CPUs, the top level inventory. But you can kind of see that left and right arrow here. It's a way to browse and walk through the hierarchy.
How documented is the Pythonic, the Python modules and things like that?
So actually up in GitHub, there's lots of information up in GitHub that talk about all the different modules that are available. The documentation is actually pretty comprehensive for each module. There's example code. I've personally, along with some of my team, built hands-on workshops for our Python SDK. We've delivered them at Cisco Live, and generally we'll try and create those and make them available up in dCloud, which is kind of our customer-facing portal for access to systems and hands-on demos. We're going to be launching a UCS programmability lab in the next coming months, which will help showcase this and give folks hands-on that might not have access to equipment.
Okay, perfect.
Yep. These APIs, by the way, these SDKs, they're all certainly free of charge. They're investments that we've made for our ecosystem, for our partners. We want customers and partners to be able to automate against the systems. We want customers and partners to be able to write their own plugins or integrations, if desired. So the last point I'm going to hit on is IMC Supervisor. We've talked a little bit about the IMC itself, this out-of-band management controller for managing our rack mount servers. We've talked about the SDKs to automate tasks. What do I do when I've got a retail store with thousands of pairs of servers in a remote site? Once if I need to recover from hardware failure, deploy that operating system, what if I need to monitor the health of all of these remote systems at the hardware level? How do I do that? And IMC Supervisor is the tool that we've built for managing hardware at scale. It supports the C-series servers. The S-series servers, although not listed, are supported here as well. The E-series servers as well. And basically, this is a virtual appliance that you would deploy in your infrastructure, and you can go out and register the BMC IP addresses or the Cisco IMC addresses for all of these remote servers and give you features like health monitoring, hardware inventory, the ability to launch remote KVMs, call home, both sending email alerts to administrators or even sending health information back to Cisco for proactive monitoring, a very important feature. There's sort of a basic and advanced version. When you get towards the advanced licensing of the product, you can do things like creating policies for and hardware profiles that you can assign to one or many servers to keep them in a compliance for hardware configuration. But in general, I think we cover a lot of ground here with this product. Firmware upgrades can be managed through this tool as well. Non-interactive diagnostic tool integration, a new feature in the latest versions of IMC Supervisor. And there's actually also a northbound API that just released in version 2.1. We'll be exploring that and looking at where we can integrate with that API. There's definitely a common theme from an API perspective. As we build a product, we really focus on the APIs and how we can leverage that up the stack with other tools. Great, so from a demo perspective, I've got about a 5-minute video that covers a few different areas. We'll look at that HTML5 interface for our IMC, the HTML5 KVM. Look at an example which I really think is a differentiator for our platforms is how we do storage management. How do you configure that RAID controller and set up your LUNs before you deploy your OS or make changes over time? We actually have the ability below the operating system to monitor that RAID controller out of band, to configure that RAID controller out of band. So we'll show you some of the interfaces that we have for doing that. So quickly logging into the IMC. This is Camtasia. I purposefully did not accelerate any of the Camtasia recordings. It's actually a very snappy interface. This is the front page. Server utilization data coming from Intel Node Manager that's built into the platform. Here's the HTML5 KVM. All the knobs and wheels that you need to connect virtual media. If you're going to actually install from an ISO remotely, you have the ability to do that. You can mount media through the KVM. You can also mount media directly from the IMC. If you've got local ISOs near the SIMC, have the SIMC mount them directly. This management tab on the left kind of centralizes all the major functions. We're going to look at the storage. So we've got a 12G SAS RAID controller on this system. The ability to completely configure out of band, again, this RAID controller. I'm going to quickly show the virtual drives installed. We have a whole, maybe about 10 drives or so. I plan to do a RAID 1 across the first 2 drives and a RAID 5 across the rest. And something I want to point out is, in fact, here's the wizard. Creating a virtual drive from unused physical disks. Again, a basic manual setup. Select the drive, the RAID level that I want. Select the drives I want in that RAID group. In this case, 2 drives in a RAID 1 RAID group. A couple of buttons. There's a create virtual drive. There's a generate XML API request. I can perform the configuration I want and then go discover what the XML is that's actually getting sent to the IMC in case I want to automate that later. And here, I've just showed that we have the ability to grab that XML data and discover what it is I'm about to send and create on the remote system. I'll go ahead and create the drives just to show that task. And again, this is all real time. I didn't accelerate anything. I found this web interface to be very responsive, very snappy for these tasks. Within a few seconds, maybe 10 seconds, I've got a virtual drive created. So up to the virtual drive tab, there's my RAID 1 volume that I just created through the web UI. Now, how would I automate that? For folks that have systems at scale, maybe they've got a whole set of servers they're setting up before they ship to these remote offices, or maybe they're doing the work remotely, potentially. I'm going to change over to my IMC Power Tool. So this is a PowerShell window with my IMC PowerShell library loaded. I'm going to log into my IMC using PowerShell and get my session information back. It takes a few seconds to authenticate and then get back session information from the IMC, generally telling me my user, the version that I'm running, the IP address of the system that I just logged into and such, my cookie. This command, and again, we need to zoom into this to really see it, but I just wanted to show that there's a large set of commandlets available, and they fall into 4 categories: adding new things, deleting things, modifying things, or querying for things. And they cover the whole range of what you would configure on an IMC. We're going to talk about the storage-related commands here. I've got a few commands that let me basically duplicate what I just did manually in the UI, create that RAID 1 volume. This next command, get command-module, is showing me, again, all of the commands related to storage. I can quickly identify the get IMC storage virtual drive commandlet. Fairly intuitive name. I think that's something that we've also done a good job on. It's fairly easy to get up to speed on using a library and automating something. And then couple that with the ability to discover the XML, I think it makes it very easy to automate something. So here I'm going to get IMC storage virtual drive, define my RAID name. What I'm actually doing here is querying for the drive that already exists and removing it with PowerShell so that I can programmatically create a RAID 1 for boot and a RAID 5 for the rest of my storage. A couple of quick commands to remove and confirm. And then again, we'll get back a return character indicating that it's, let's pause here really quick. Oh, perfect, there is a pause, thank you. So this is just a couple of one-liners I put together. A literally one-line command to create a RAID 1 from drives 1 and 2. And for folks that are familiar with PowerShell, I find this to be fairly intuitive. Our PowerShell modules are self-documenting. As you're tabbing through and you're running a command, it quickly will show you all the available arguments that are available with a command. We've got great documentation. The user guide, in fact, for our PowerShell library, is really loaded up with examples for using each of the commands. So these 2 commands basically create a RAID 1 on the first 2 disks and a RAID 5 across the remaining disks 3 through 10. So in a second here, I think I'll just copy and paste this and literally throw it into my PowerShell session. And again, pretty responsive environment I found in general. These commands will go in and probably 10, 15 seconds or so we'll get back for each one. And again, I think the value here is the fact that this is out of band. I don't need to go into the operating system and load agents to program the RAID controller. This can be completely done out of band remotely, which I think is pretty powerful. Same capabilities with Python. So again, we've got Python for IMC. It's constantly getting updated. A lot of development work being done there. We're at what I would consider a very mature beta on the Python library. Actually, I'm sorry. Python for IMC is GA. Python for our UCS Central product is in a mature beta at this point. So we executed the 2 commands. I'm just showing now that I'm going back to the UI and seeing the 2 RAID volumes that I created. But again, fairly lightweight in terms of the time it takes to get this configuration done. And aside from storage, I wanted to focus on storage because that's generally a pain point. A lot of times you do need agents, or you're interacting with the operating system, or at least some pre-boot environment post-BIOS to configure the RAID. We've got basically our IMC has its own dedicated connection talking to the RAID controller out of band, which is important for monitoring the health, but also for automating and configuring as well. Now, this is the storage config, but when we looked earlier, that menu structure up top covers the whole plethora of what you would want to configure on a rack mount server, setting your BIOS settings, firmware levels, your BIOS boot order. You can programmatically change your server to boot from different devices, which I think is a great lead into the next section of how do I deploy these operating systems remotely and ideally in a non-interactive manner, especially if I'm going to automate against many systems. Let's see here, we'll go next slide. So this is actually this NISCU that I'm going to refer to is a brand new tool that's been built. It's actually posted on Cisco communities, and this literally got posted January 31st. So what is that, 2 days ago? So the server config utility is something that basically comes with the product. When someone receives a new rack mount server, they generally go and grab SCU. It's an ISO image that allows you to interactively deploy any supported operating system. It basically feeds the drivers in during an automated or scripted installation. NISCU is basically a set of Python scripts that you can download and use along with the server config utility ISO image to do a fully non-interactive scripted OS installation. I ran through this recently. I didn't have a chance to actually record a demo. I'm going to record a demo. I was hoping to have it for this session, but I ran through the tool. It's actually very well written, and there's a couple of config files. At a high level, what the scripts are actually doing is leveraging all the capabilities of the SIMC to mount remote media. I can, again, have the SIMC mount ISO images directly without me having to launch a KVM. And those ISO images that are involved would be the operating system ISO image and the SCU ISO image, which contains a set of drivers, supported drivers for all the various operating systems that we support. So you can set up a couple of config file entries defining how to get to these ISOs. We support all the usual protocols like HTTP or HTTPS or CIFS. Once you've got your mappings defined, you literally just launch the script, and everything is automated from that point. I can kind of monitor the script if I want to. I can take a look at the SIMC side and see that the mounts are happening, that the server's booting automatically, that it's if I open the KVM, I can watch it transition from the SCU boot window into the scripted installation of the operating system. But ultimately, one task, and after the process is completed, I've got my operating system installed with drivers injected. So it's certainly a great tool. I look forward to introducing this to a lot of our customers.